So in this video I'm going to discuss Codeforces around 941 rated for Division 2. So I will be solving first three problems of this problem set. So let's start with problem number A, that is card exchange. So in this question we will be given n cards and each card will be having a number written on it, and also you will be given a fixed integer k, and you can perform a operation like you can choose any k cards from your set of cards such that all the k cards have the same color. After that you can exchange these k cards with k minus 1 cards, and you can put k minus 1 card of any number in the set again. So you have to tell them what is the number of cards left at the end of the sequence by performing this operation some number of times. For example, in this case, if you are having a set like 4 1 1 4 4, you can, and you are having a k of 3, then in the first step you can choose 3 fours and replace it with 1 and 3. Then your final set will become 1 1 1 and 3. Then you can simply repeat the process, and that's how you will be left with 1 and 3 only. So what is the minimum number of cards left at the end of the process? So the problem is pretty much straightforward. If you are having, if you're in your current state, if you're having a cards of same number greater than or equal to 3, then at the end of the sequence you will be left with k minus 1 cards. Else you cannot make a single move, because if you do not have a, because if you do not have a single number with at most k number with which is occurring at most k times, you cannot even perform a single operation. So in that case the answer is simply the existing number of cards. So that's how you can solve the problem number A. So let's now discuss the problem B, that is B, rectangle filling. So this question is pretty much interesting. So let me tell you the approach here. So first of all, let me construct a grid over here. So in this question you are only your only concern is with end rows and end columns. Okay, you do not want to worry about these set of columns. Okay, in the answer. So if your answer, simply let me teach you first of all the what is the question asking you to do. In this question you can simply select any two boxes of same color. For example, in this case the computer has chosen this white and this white, and select the sub rectangle which is formed by these two squares. Okay, then color all the sub rectangle between these two squares with the same color as the diagonal color which you have chosen. Like this is white and white, then make all the colors between them as white only. Okay, now after some number of operation you have to tell them whether it is possible to make all the colors in the rectangle as the same or not. Okay, so the question is pretty much simple. So let's now discuss the solution. So if you're having the same color on the diagonal, let's suppose if you're having the same color on the diagonal, suppose if you have white hair and white hair, then your answer is yes. Okay, or you have black hair or black hair, then your answer is also white. Okay, yes, answer is also yes. Similarly, if you're having white or white in this diagonal, or black and black on this diagonal, then in that case your answer is yes. Which means what I'm trying to say, that you have to only check the diagonal of your current square. If the diagonal of if the because there will be two diagonal in this square, either it will be this diagonal or either it will be this diagonal. You have to check whether these two diagonal have the same color, because if these two diagonal have the same color, then you can simply select the whole grid, and the whole grid will be the same color at the end. Okay, and similarly for the this diagonal also. But what if the diagonal color are not same? Okay, so let me take the case that case also. So in this case, let it is white, which means this color cannot be white, so let it be black. Okay, so let me take now, so let this color be white, and this color, now this diagram cannot be white because I'm taking a case in which none of the diagonal are of same color, which means this can be black. Okay, so tell me, like if you are having a white, like if you're having a white over here in these two, in this between two blacks here, if you're having a white between these two blacks, okay, then you can select that white. Okay, let me tell you once again. First of all, the condition is that none of your diagonal is of same color, because if you if your any of the two diagonal is of same color, then answer is yes. but in this case your none of the diagonal is of same color, which means they are of opposite color. Now try to check whether if this color is white. Now try to find white between these two blacks. Okay, if you're able to find white between these two black, then answer is yes. But why? So let me tell you why. So let's suppose this color is white. Okay, let this color is white. Then you will choose a grid like this. You will choose a grid like this and make all the colors and make all the color as white in between them. Okay, which means at the end this black would contain white. Okay, and you know your this diagonal is white, and by choosing this white and this white you will try you can make a bigger rectangle as this and make all the colors at white. Okay, similarly, hope you have gotten the solution. But wait a minute, let me tell you another way around. Suppose these two are black, and if you found a black between these two whites, if you found a black between these two whites, okay, let's suppose you're finding a black over here. Okay, then you can choose a grid like this black, and make this grid of black color only. If you make the grid this black color only, then this would be black. Okay, and this would be black, and you know the opposite diagonal is also black. Then in that case your both the diagonals are of the same color, and the answer is simply yes. So that's how you can solve the problem. But there is also another case. So in this question you have white and white on the same vertical line, but if you have same white on the same horizontal line, which means I'm trying to say a case like this. You have black here and white here. Okay, so in this case you will try to find white in this black. Okay, you will try to find white between these two blacks. Okay, if you found a white over here, then simply select this square and make this black equal to white, and at the end choose this white and choose this white and make whole the rectangle as white color only. Another way around would be like this. Try to find black between these two whites. If you found a black between these two whites, then simply select that black and make this as a grid. By making this as a grid, you will make this white as a black. Okay, and simply then you can simply choose this black and this black and make whole your rectangle as black only. So that is the only problem solution. So hopes you have got the solution. If you want the code is in the editorial part. You can simply check it here also. This is the same code which I am trying to say. Oh, let me this is the same code which I'm this is the same approach which they have used in this question only. So let me now discuss the problem number C, that is everything's name. So in this question, Elias and Bob are playing a game on n piles of stone, and on each turns they will select a positive integer k that is at most the size of the smallest non-empty pile, and remove the k stones from the each non-empty pile at once. And the player who is unable to make a move because all the piles are empty, they loses. Which means the player who has made the last move wins. Okay. So if the both the players play optimally, then who will win? So this is a pretty much easy problem. Let me tell you why. So let me tell you first a case. Like if you have a case like if you have a number in increasing order. Okay, let me first take a case. If you're having a number in increasing order, that is like 1, 2, 3, 4, 5, 6, 7. Let me take it till 7 only. First of all, understand this test case, then you will get to know how to find the solution of in each and every test case. So if you are having a number like in the increasing order from 1 to 7, so you does not have a operation, you does not have a operation to left. You have to only choose one, because 1 minus 1 is 0. You cannot choose a 0 as operation. So the only move left with the first person is 1 only. So let me take Elias is moving, and Elias is moving this operation, and after Elias operation, this array would now become like this is 1. Now this will become 2, 3, 4, 5, 6. Okay, great. Now Bob will turn. But now what Bob can choose? So the minimum possible number in this sequence is 1 only. Then again Bob will have only one choice left, that is by choosing 1 only. So the Bob will choose 1. Okay, the Bob will choose 1. So okay, now what next? Now the array would become like 1, 2, 3, 4, and 5, and this is Eli's turn. Okay, now Eli is now also having a only one option, that is choosing 1. So by choosing 1, the array would become like 1, 2, 3, and 4. Okay, now whose turn is this? Now there is Bob turns. Now Bob is only having one option, by choosing one as operation. Now, in the next turn, the array would become like 1, 2, 3. Now Eli's turn. Now Eli's is also having now one operation, that is by choosing 1. Now the array would become like 1 and 2. Now there's again Now there is again Bob's turn. So what Bob will choose? Bob will only choose 1 because there is only one option left. So after that array would become like 1. Now in the next turn is of Eli's. Okay, next turn is of Eli's. So Eli's will choose 1 only. Now this one would become now 0. Okay, great. So tell me, on what factor answer is depending? So you know one thing, that for if you are having a sequence in increasing order, then Alice and Bob does not have an option. They have to choose one in each and every operation, and the number of operation would define the winner. Because in this example, you are having total number of odd numbers. Okay, you're total having odd numbers. So in the case of odd numbers, Alice wins because the last move was made by Alice. So what if your number are odd? If your numbers are even, so if your numbers are even, then Bob will win. Okay, so let me repeat it again. So if the numbers are odd, then Alice will win. Okay, this is less. If your numbers are even, then who will win? Then Bob will win. Because in the increasing order, only the factor which is depending on the answer, if in the increasing order, the answer is simply depending on the number of elements. If the number of elements are odd, you have seen, in the odd case the allies is winning, but in the even case the Bob will win. So so please remember this part because it will help in the further solution. So let me now take a random array. In that case, so let me now take a random array, and in that case the okay, this is grid. Okay, sure. So let me now take a random array. Let's suppose 1, 2, 3, and this is not increasing. So let me skip 4 here. So now simply write 5 over here, or let me write 6 over here only. 6, 7 and 8. So this is the random array. So first of all, tell me, if you are having an array like this, then uh, allies will now in the first operation, allies would only have one operation, that is choosing one. Okay, so what allies will choose? Allies will choose one only. An array would become like 1, 2, and here it is 5, and here it is 6, and here it is 7. Okay, great. Now what Bob will choose? Now Bob will only having a one option left, that is choosing one only. So now and after Bob's operation, the array would become like 1, 4, 5 and 6. Okay, great. Now the turn is of allies. Now after allies turn, the array, but how array would look like? The array would look like 3, 4 and 5. Okay, great. Now this is the turn. Now this is the Bob's turn. Okay, now this is the Bob's turn. So now you can see Bob is now having two options. Either he can choose 3. Okay, by choosing 3 he will decrease 3 from each and every part, or he can choose a number which is smaller than 3. Okay, he can choose an operation which is smaller than 3. So what operation Bob will choose will decide the answer. Okay, so you know one thing, that the if your numbers are odd, then the person who is starting the game is winning the game. Okay, if your numbers are odd, the person who is starting the game is winning the game, because in this case Elias is starting the game and the numbers are odd also, then Elias are only winning the game. But how this chess case is related to this chess case? So let me teach you why. So now Bob can make array like this. Okay, now Bob can make array like this in the increasing order from 1 to till any number n. Okay, now Bob's goal is to make array in the form of 1 to n. Okay, but how Bob can make a array in the form of 1 to n? He will now have a two option. He can either select 3, because because now you know your current array is in increasing order, because yes, you know now your current array is in increasing order. So if Bob choose a number 3, okay, if Bob choose a number 3, then array would become like 1 comma 2. Okay, great. But if Bob choosing number 2, but if a Bob choosing a number 2, then you know the array, like this is the first test case. If a Bob chooses a number as 3, now if a Bob chooses a number as n minus 1, that is 3 minus 1 as a 2. So if a Bob chooses number 2, then array would become like 1, 2 and 3. So you know now that Bob is now having a control to making an array like this, or to make an array like this. And Bob knows if he makes an array like this, then you know what, now Elias would if Bob's make an array like this, then Bob's know he will win because the numbers are odd, and the next turn is of allies, and the person who is turning, whose turn is that? Let's suppose in this case the turn is of allies. Okay, because after Bob, allies would take a turn. Okay, so now you can relate this test case to this test case. If your numbers are in increasing order from 1 to n, and the person who is starting the game can only win if the further number are in the odd number, if the further total number of numbers further are odd. So you can see the further numbers are are even, which means in this case Bob will win. Okay, but you know what, if Bob chooses this test case, if Bob now chooses to make array like this, then the turn is of Elias. And if your numbers are increasing order from 1 to n, and the numbers are total number of numbers are odd, the then the player who is starting the game would win the game, because in this case the lies would win the game. So now Bob will always try to win. Okay, so the Bob will always try to optimally choose a move between these and those, this move and this move. If after choosing the move, the numbers of the total number of numbers are total number of numbers are remain to be even, then the Bob will win. If the total number of numbers are remain to be odd, then the allies will win. This can be another way around. Let's suppose the last case was of allies, and last number, let's suppose at this position allies would be there. Okay, because allies can also come at this position. Then allies would have two cases. Like he can make array like 1 and 2. He can make an array like 1 and 2, or he can make an array like 1, 2 and 3. And the allies knows, if he chooses if he chooses this part, then the Bob will lose. Okay, if he chooses this part, then Bob will lose, because Bob is starting the game and the number of numbers are odd and the number of numbers are even, and Bob is starting the game, then Bob will definitely lose, which means allies will win. So allies will try to make an array like this and not like this. So which means what I'm trying to say, that like that the person who is ending the game at here will always win. If I repeat, the person who is ending the game at this position would always win. Or I can more generalize it. Like if any player if any player have a choice of choosing a number which is not equal to 1, will win the game. Okay, let me repeat again. If a person is having a choice to choose a number which is not equal, if a person, let me repeat again, if a person is having a choice to choose a number which is not equal to 1, then that person will always win the game, because he can make a array like 1 2 or 1 2 3, which means he can make a array like, he can make the final array of odd size and even size, and the size of array will depend the answer, because I have teach you here that how the size is depending the, because how the answer is depending on the size. Okay, so how you will get this? So first of all, you can find the max of the array, that is the smallest number which is not there in the array except the 0. Okay, leave the 0 for this part and find the max of the array. What is max? The smallest number which is not in the array. If the smallest number which is not in the array is greater than the largest number, okay, for example in this case, your max is, in this case your max is 8, and your max is greater than the largest number of the array. If your max is greater than the largest number of the array, in that case the parity of your size will depend the answer, will decide the answer. If the size of the array is even, then the Bob will win. If the size of array is odd, then Alice would win. Okay, but if in this case your max is equal to 4, your max is equal to 4. If your max is not equal, if your max is smaller than the largest number in the array, then the parity of max would define the answer, because that is the number of steps required to come at this position. Okay, if your max is 4, if your max is 4, then the required number of, because if your max is 4, then at the fourth operation the Bob is reaching at this position, and the Bob will also win. If your max is equal to even, if your max is equal to, let me repeat again, if your max is even, then Bob will win. If your max is odd, then Alice will win. Okay, but in this case your max is smaller than the largest number. Okay, because you can see if your max is 4, then Bob is taking chance on this test case in which he is having a choice by choosing a number greater than 2, greater than or equal to 2, and that is a deciding factor of whole the solution. Okay, hope so you get the solution. Let me now generalize the solution. If your max is if your max is greater than the largest number, then the parity of the size would define the answer, and this is how it is defining. And if your max is smaller than the largest number, then the parity of max would define the answer. So that's how you can find the solution of the problem. See, so if you want the code you can find in the editorial part itself, because that is the same approach which they have used also. So this is the output, this is the code. So if you have doubt in any of this solution, you can always comment me down, and please don't forget to subscribe my channel, and please share the channel video all the CP mates and share it in your all the university channels, like as you wish. So this is all for the today's video, so stay tuned for the next one. Thank you.